Hey guys, welcome to another theory of computation tutorial. Today we'll be looking at some more examples of NFA, that is non-deterministic finite automata examples. So let's get started. First thing, what are we going to learn? We'll look at two examples, first and second example. So let's begin with the first example. Design a NFA for the transition table as given below. So this is the transition table that they have provided. So the language has two alphabets, 0 and 1, and we have got four states, A, B, C, D. All right. So let's see, A is the starting state. As we can see the arrow here, A is the starting state. In state A, if we get 0, we go to state A and B. Okay. So if we get 0, we go to state A and B. We go to state A and state B. Okay. What about 1? If we get input 1 in state A, then we go to state A and C. So we'll go to state A and state C. Okay. Now we have covered state A. What happens in state B? So let's say we're in state B, we get input 0, we go to a null state. So there is no need to show that. What about the 1? If we get input 1 in state B, we go to state D. Okay, so we go to state D. Alright. Now we have covered state B. Now let's look at state C. So in state C, if we get input 0, we go to state C itself. And if we get input 1, we go to state D. Okay. Now let's look at for state D. If we get input 0 and 1, we are still in state D itself. So we go from state D to state D only, even if the input is 0 or 1. So this is how we design a NFA based on the transition table. Alright, now let's look at the next example, example number 2. So construct a NFA accepting all strings with 001 as a substring in it. Okay, so we have to construct a NFA that has 001 as a substring in it. Okay, so the solution is like this. Let's make a basic NFA first. Okay, so let's say our starting state is A. We get input 0, we go to state B. Again we get input 0, we go to state C. And again we get input 1, we go to state D. And let's make this state D as our final state. Okay, so now this is going to accept the strings like 0, 0, 1, and it is coming to the final state. So this string is accepted. Now the starting can be anything, 0 or 1. Fine. Similarly, once it has 0, 0, 1, at the end it can be any 0 or 1. So this is how we design a NFA. Now let's test it out. So let's say we have a string, let's use green color. Okay, so let's say we have a string 0, 0, 1, 0, 1. Okay, now let's say we are in state A. Okay, starting state A, we get input 0. We'll be going to two states, that is A or B. So let's say we get input 0, we go to state A and B. A and B. Okay, now over here, if we get again input 0 in state A, again we are going to go to two more states, that is A and B. Correct? A and B. And in state B, if we get input 0, we go to state C. Okay, now after that we get input 1. Okay, so if we get input 1, we stay in state A over here. In state B, if we get input 1, we are going to null state. Okay, so we are going to a null state. What about state C? If we get input 1, where are we going? We are going to state D. Okay, after that in state D, if we get input 0, okay, if we get input 0 in state D, where are we going? We are staying in state D itself. So we get input 0, we go to state D. And in state D we get input 1, we are still in state D only. Is any one of these three states, that is A, null, and D, a final state? Yes, D is a final state. So hence this string is accepted. Okay, so this is how we design a NFA or construct a NFA based on the strings. Okay, so that's it for today guys. If you have any queries, feel free to ask me in the comment section below. Thank you very much.